All right, so unit 4, lesson 3, so integral exponents. So we're going to go through here, fill out this quick chart here, kind of an investigation. Remember, anything to 0 power is 1, so we kind of fill that across the board. Okay, remember, with 10 to the negative 1, essentially you're pushing any negative exponent to the opposite numerator or denominator. The other way you can think about it is it's 1 times 10 to the negative 1, which from our measurement unit, we moved the decimal point left 1. It's now 0.1, which is 1/10. Okay, same thing for 10 to the negative 2. I moved over 2 spots. It's now 1/100th. Okay, or 0.01, which is 1 over 10 squared. Okay, same thing again. 1, 2, 3. I have 2 zeros. It's 1/1000th, which is 1 over 10 cubed. Okay, and again, it kind of goes with everything. So that means we're going to have 1 over 3, 1 over 3 squared, 1 over 3 cubed, 1 over a squared, 1 over a cubed. Okay, last part of the repeat here. Oh, dang it. Oh, there it is. Sorry. Okay, so here we go. So these ones we already did. So remember, 10 to the negative 7th makes 1 over 10 to the 7th. 3 to the negative 5th, 1 over 3 to the 5th. And 1 over 8 to the n. Okay, so now this is the part we're getting to. So consider expression. We're going to prove this using exponent laws. 5 to the 4th divided by 5 to the 7th. Okay, 5 to the 4th divided by 5 to the 7th. So what that means is we're going to have 5 or 7 5s on bottom. 1, 2, 3, 4, 5, 6, 7. Okay, so they cancel. So we have 3 on the bottom. Okay, but using our exponent laws, what's our exponent laws? 4 minus 7, which is actually a what? No, negative 3. So if it's a negative 3, it's where? Bottom. 5 is negative 3. This is the answer. 1 over 5 cubed. 4 minus 7 gives me a 5 to the negative 3, which means it's a push down. It's 1 over 5 cubed. No. Negatives go opposite of where they were. You can't say it's top or bottom. It's opposite of where they were. So where it was in the first place, this right here, if it's not anything, what's the number 2? It's 2 over 1. It's on top. Okay? Coming from Mike. That's. Hey! Yeah, what about George? Okay. Why does it do that to me? It only does it on this workbook. That's the weird thing. What page is it, Chris? 77? 77? Alright, so, sorry about that. Okay, so write the following positive exponents and evaluate. Okay, so, last part here, sorry. The results are examples of the general rule. When a base is raised to a negative exponent, you flip it to the bottom. So this will just be, a to the p on the bottom. Okay, write the following positive exponents and evaluate. So this makes it 1 over 2 to the 1, which just makes it 1/2. Okay, or 0.5 if you were to do a decimal. Okay, this one would be 1 over 3 squared, which is 1/9. Okay, this one is 1 over 4 cubed, 1 over 64. Okay. All right. So now we're talking about with the negative exponent in the denominator. This is why I said you can't say the negative goes on the top or bottom. It matters where it's at to start. Okay. So use the rule for division of fractions to show that 1 over 4 to the negative 3 is actually 4 cubed. Okay. Stop the clicking. Okay. So we have 1 over 4 cubed. So there's essentially, how can I write 4 with an exponent that equals 1? No. How do I get a 1? So 4 to what power equals 1? 0. Okay, so I'm going to write this as 4 to the 0. So then 4 to the negative 3 is on bottom, correct? So now I have the same base. So now we can do our nice division rule. Okay, our division rule is 0 minus a negative 3. What's minus a minus? Positive 4 cubed. We just proved it using exponent laws. So it's minus a minus. It's minus a minus. Okay, so then the negative exponent law simply means if it's negative on top, you push it to the bottom. If it's negative on bottom, you push it to the top. That's all it is. Okay, wherever your negative is, push it to the other numerator denominator. Okay, other numerator denominator. Questions yet? Nada. I know what it means, thank you. Actually means nothing if you knew your Spanish. Okay, let's get these examples here. Slowly but surely. Don't laugh, it encourages them to keep being dumb. Yeah, you are special. Okay, I don't want to say it. Okay, so 4 to the 5 times 4 is negative 3. So we still have our same exponent laws, which means we add. So it's going to be 4 to the 5 plus a negative 3. Well, plus a negative is the same thing as subtraction. Okay, so this is going to be 4 squared. Okay, 4 squared we know is 16. Am I going too fast? Are we okay? We still wish the power's out. Okay, 3 squared times 3 to the negative 5. 3 squared times 3 to the negative 5 means it's going to be 3, 2 plus a negative 5, which is 3 to the negative 3, which is 1 over 3 cubed, which is 1 over 27. Okay, 1 over 2 to the negative 5th. It says negative on bottom. We're going to push it to the top. It's simply going to be 2 to the 5th. 2 to the 5th is 32, I believe. This is a good one. A lot of negatives. This is kind of what Mike was talking about earlier. So negative 7 minus a negative 5. So I have a negative 7 minus a negative 5. Minus a minus is a plus. Negative 7 plus 5 is 6 to the negative 2. Okay, that gives me 1 over 6 squared, which gives me 1 over 36. Yep. Okay, and what's the rule for power to power? Multiply. So negative 1 times 3. So I get 2 to the negative 3. Okay, that's going to give me 1 over 2 cubed, which gives me 1 over 8. Nice. Okay, so we're saying true or false. So let's keep going around here. Molly, is this one true or false? Part A on 2. Is 8/3 over 8 negative 1 equal to 8/4? Yes, it's true. 3 minus a negative 1 means plus 1, which means 8/4. Okay, Allie, how about this one? Xander, stop whistling. What do you have to do in order to add or subtract exponents? What has to be the same? Same base. Are these same based? No, so we can't do anything, so this is false. Okay, we can't do anything, it's false. Okay, good. Josh, is a negative 3 equal to 1 over a3? Yes, true. This gets pushed down. Okay, good. And Chris, is 9a negative 3 equal to 1 over 9a3? False, because the 9 will still be on top. This does get pushed down, but the 9 can't get pushed down with it. It has to be all in parentheses to be both good. It's because the negative 3 is only on the A. So the A is all that can be pushed down. The 9 would stay on top. Tricky. Yeah, if it was all in brackets, it'd all get pushed down. Yep. Good, good. Okay. Sander? Was that Mike? Oh, stop whistling. You guys keep whistling and clicking back there. I hate my job. Okay. All right. So 8, negative 4, 8, negative 3. That's going to be A, negative 7, right? Because we're going to add them. And then where does that go? Bottom. 1 over A7. Okay. This one here. What's 6 divided by 2? 3. What's 2 minus 7? Negative 5. What do we do with negative 5? Push it down. Okay, so I'm just following my exponent laws. I'll slow down. So 6 divided by 2 is 3. 2 minus 7, because our exponent laws is negative 5. Since that's negative 5, we push it down. The 3 stays on top because it's not part of the negative 5. Okay, this one here. 6 minus a negative 5. What's that? 11. So it's 11 on top over 2. Atta boy. Thanks for lying. What's that? Well, it's 6 minus a negative 5, so it's a y11, so it's on top. It's positive. If it's positive, it's on top. Yeah, it depends where the negative are. Like, you can't. Okay, this one here. Going to hit both of those. So it's going to be negative 2 to the negative 3 and x to the negative 3, which pushes them both down. Okay, and that's going to be negative 2 to the negative 3. What's that actually? Yeah, it's going to be negative 8 down here. And this is going to be x3. Okay, if you're asking, well, wait, why is this negative and this one not? Well, this has a negative sign with it. This doesn't. Another way you can do this one, it might be easier, is you could have just took the whole thing and just took it down here as a cube. That's fine too, and then simplified it. Either works. Okay, part E, 8 divided by 4 is 2. Negative 5 minus a negative 3 is a, minus a minus, it's going to be negative 2. Because negative 5 minus a negative 3 means plus 3. So that's negative 2. I'll push the a down now. I keep the 2 on top. 2 over a squared. Oh, holy moly. Wait. Sorry. There's a's and b's. A's and b's, sorry. So take the b's, put them on top. Take the a's, put them on bottom. So 8 over 4 is still 2. The b3 goes to the top. The a5 goes to the bottom. Excuse me. Sorry. Thank you. I appreciate that. It makes a lot of sense. He might not miss you, though. Tired of those math scores. No. I never drop kicked him. Okay, so this hits both. So 5 to the negative 2. P to the negative 2. So all these move down. Okay, so that's going to be 5 squared. There's already a 5, 1 down here. So if I move a 5 squared down with a 5, 1, how many 5s do I have? 3. So I have a 5 cubed down. And then I have a Q4 and a P2 down. So everything was down with a 1 on top. Now it's horrible handwriting. 5 cubed is 125. So that makes it 125 P squared Q4. Order doesn't matter. I just put an alphabetical. Okay, we got two more examples. I'm going to talk about fractions real quick. Okay. Okay. All right, so this one's got a lot going on. Okay, a lot. So when you divide fractions, what do? Well, yes, but how do you divide fractions in general? You flip and multiply. So I would do that first. Okay, so I would go 5x3 y negative 8 z negative 2 times x5 y negative 3 z2 all over 15 x8 y3 z negative 1. And now I'm going to go ahead and times the top, and then I'll do the quotient. Okay, so x3 and x5 make an x8. Okay, so I have 5x8 on top. Y negative 8 and negative 3 make a negative 11. Negative 2 and 2 cancel. Okay, so the 2's are gone, or the z's are gone. Okay, the bottom is still 15x8, y3, and then z the negative 1. Okay, what does 5 over 15 reduce to? 1/3. Okay, that's done. x8 over x8 cancels. 8 minus 8 is 0. Negative 11 minus 3 is negative 14, so that's on the bottom. And then that's done. And then we have a negative 1, which we'd push where? Top. So we have a z on top. And that's it. Very good. All right. Okay, again, so we already talked about this twice. Explain why this is not correct. The negative 3 exponent is not on the 2. Yep. The correct answer would be 2 over P3. Okay, and we're just going to talk about fractional, which isn't anything new, so that's good. All right, ready? Perfect. Okay, so this is going to be kind of a lot of flipping going on here. Okay, so consider you have 2/3 to the negative 4, right? So what they did here is they took this and they put it on bottom to the 4th. The whole package, moved it down, and made a positive exponent. What do we do with fractions and exponents? Yep, to both numbers. So it's going to be 2 to the 4th over 3 to the 4th. Okay, now in fraction-wise, if I have 1 over 2/3, what do you guys know, like what happens when you have that? It's kind of hard to explain. This is essentially 1 divided by 2/3, right? So what's the rule? Right, so essentially, now this is what Chris is saying if you're not following. When you divide fractions, you flip and multiply, right? A 1 is 1 over 1. So it's 1 over 1 times 3/2, which essentially puts the 3 on top. So when you divide a fraction by a whole number, you need to take the bottom to the top. Okay? I will tell you another thing. Whenever you have a negative exponent, just flip your fraction. That's what they're trying to prove to you right now. So if you have a negative exponent, flip your fraction and put 4s on them. That's kind of the better way to think of it. Yeah. Okay, so because you see what happens now? The 3/4 is on top, and I have 3/4 over 2/4. So what do you notice? Or excuse me, yeah. So 3 to the 4th, 2 to the 4th, down here. It's because the negatives flip them. This is the other reason why. Let's do it this way. We know the negative 4 hits everything, right? Yeah. So if I have 2 to the negative 4 over 3 to the negative 4, well, they're both negative exponents, they're both going to what? Flip spots. That's going to go up here. That's going to go down there. Would they flip spots? Yes. Okay. Are we good? Okay, so then that gives me, when I actually do this, that's going to be 81 over 16. is the actual answer there. Okay, and that's what this is. Classify the following as true or false, and so what it's showing you is, see, it's doing exactly what I told you. This flipped is the same thing. So if you have the negative, flip it and make it positive, and then hit top and bottom. Are there any questions with that? 'Cause I know fractions are confusing. Okay, so here's the rule right here for you. So let's talk about this one. How do I do that last one on D there? So what would you do? It'd be what cubed over what cubed? Positive 2 cubed over 5 cubed, which would be 8 over 125. That would be that one. Flipped them, cubed them. We flipped because of the negative, cubed because we had a 3. Okay, and then there's your rule right there at the bottom. Okay, if I was